Hello everyone. I hope you all had a chance to attend the first day of Google's 5-day course on AI agents. I have created this video to share what I have learned in a simple and easy to understandable way. Hopefully it helps anyone who is curious about AI and wants to know more. First, we will quickly define what are AI agents. Then we will look at the different levels where the agents operate from simple to complex. Next, we will understand why AI agents are becoming so important in today's world. After that, we will explore how AI agents use tools and how they are managed and how they execute tasks. Then we will break down the basic blueprint of an AI agent, and then we will also cover smart ways to design agents, especially when many work together. And finally, we'll discuss about how to get agents working and talking to other systems in the real world situations. And then we also touch upon on the interoperability and interactions and the security concepts. Yeah, this is the simplest example I came up with to explain what agents really are. So imagine a mom asks dad to make a coffee, and every time a dad asks a bunch of questions: how much milk and how many spoons of sugar he needs to add and how strong the coffee should be. He needs all the details step by step to even to perform a simple task. He needs to be told exactly what to do at every moment. But then when the dad asks mom to make a coffee, she she just does it. She knows his preferences. She decides how much milk, sugar and coffee to use without asking every time. This is how the agent works. It understands the goal, figures out the steps on its own without needing constant instructions. So let's break down the AI agent with mom making the coffee. The model is like her brain, holding all the knowledge about dad's coffee's preferences, like how much milk or sugar he likes. It is her understanding how to make the coffee. The orchestration layer is her brain at work, creating the plan for how to achieve the goal, making the perfect coffee. Tools are the things she uses, like the coffee maker and the grinder. They help her to do the work. Memory is the part that helps her learn over time. For example, if dad asks for a little more sugar one day, she will remember that and adjust the coffee next time. I mean, deployment is like the kitchen where all the actions happen. It is the environment where the mom makes the coffee. So, an AI agent is like a mom using her knowledge, memory, tools, actions to achieve the goal without needing to be told every little thing. This process is called the agent loop. It's like agent's daily routine to get things done. So so these are primarily five steps. The first step is to get the mission. First, the agent gets a goal, just like mom getting the mission to make the coffee for dad. The goal is clear: make a delicious cup of coffee. Next, she checks what's around her in the kitchen: the coffee beans, the milk, and the sugar. That's what we call scanning the scene, gathering all the context she needs before starting. Next step is think it through. Now she plans her next moves: how much milk to pour, when to start the coffee maker, how long to brew. This is the agent's thinking stage where it makes a plan based on the goal and what it knows. The next step is to take action. Then she gets to work, make the coffee using her tools like a grinder and the coffee machine. The, the agent does the same. It executes its plans using tools, apps, and systems. Next, finally, she tastes the coffee or waits for dad's reaction. Maybe he says a bit sweeter next time. So she learns and improves for the future. That's what observing and iterating means: learning from results and getting better each time. So that's the agent loop. Get the mission, scan the scene, think it through, take action, and observe and iterate. Just like mom perfecting her coffee recipe, an agent keeps learning, adjusting, and improving until it nails the perfect results every time. So we can classify the agentic system into a few broad levels, each building on its own capabilities. So broadly into four levels. So maybe to explain this each one of the level, Maybe we'll reverse the role and now make the dad as an AI agent, and his task is to make a good, delicious coffee for mom. So that the first level, so dad is like a basic language model. He knows how to make a coffee, but only in theory. He still asks how much milk, how many spoons of sugar every single time. Without clear instructions, he can't take actions on this. Now, a dad is a bit smarter. He connected to the tools, the grinder, the kettle, the spoon. He doesn't ask for every detail anymore. He just knows mom wants coffee and gets started using his tool. He's no longer just thinking, he's acting. The next is the dad starts planning ahead. He says, I will grind the beans first, then boil water while warming the milk. So he's organizing the steps efficiently like a chef who knows how to multitask in the kitchen. The next is the collaborative multi agent system, where this is where now the dad and mom join forces. Mom checks the pantry, prepares the cups while dad brews the coffee. They coordinate, divide tasks, and communicate, just like AI agents that work together to solve the complex problem. So here, dad and mom have become agents, and then they work together, which is called the collaborative multi-agent system. The self-evolving system, and finally, the dad becomes a self-evolving system. He notices mom prefers oat milk, so he adjusts. He tweaks the grinder settings, maybe even upgrades to a smart kettle that learns over time. Now, he's not just following the instruction, he's learning and improving with every cup. So that's how dad evolves from a simple instruction follower into a full fledged AI system. So, one that understands, plans, acts, collaborates, and keeps getting better over time. Now that we have seen how agents think and act, let's see what they are made up of. Every AI agent has three main parts: a brain, hands, or the tools, and the nervous system that connects everything together. So, the first is the brain, the model. So, we have the model which is like a agent's brain. This is where reasoning and decision making happen. Choosing the right model means picking the right kind of brain, one that can think, plan, and adapt to the goal. For example, Gemini 2.0 Pro, Gemini 2.5, Flash are the two types of brains, one powerful, deep, and the other fast and efficient, depending on what the agent needs. So, in some scenarios, we are not limited to use only one agent or a one model. There might be cases where we might have to use two different models for each one of the agents. So, one model we can use it for the text generation, and the other model we can use it for the image and video generation, and then we can collaborate it. So, next we have the tools. These are the agent's hands. They let the agents actually do things in the real world. Say the action oriented tools where it can handle tasks like sending emails or checking your calendar. Human in the loop is also one of the tool where the agents waits for the human's response. The search tools which can help the agent look up the information from the web or your inbox. The web search tools, the famous are DuckDuckGo, which is a web search, Google search. So without these tools, the brain can think all it wants, but it can't take action. And connecting these two, the model and the tools in the orchestration layer. Now, how do the brains and hands work together? That's where this orchestration layer comes in, like the agent central nervous system. It connects the model's thinking to the tool's action through something called Model Context Protocol or MCP. And it's what allows the agents to call different tools, get results, and keep looping through the process: think, act, and observe. So e- everything stays in sync, just like how our brain, hands, and nerves work together when we make a coffee. In short, the model thinks, the tools act, and the orchestration layer connects it all. Together, they form the core of how every agent comes to life. Yeah, in this slide, we will discuss about the design choices on various tools we have to build effective AI agents. First is the autonomy. So while you are building the AI agents, you need to choose what is the degree of autonomy You are allowing your agents to act. So some agents follow fixed step. This is a low autonomy. Others can plan and adapt using the language models. This is called high autonomy. So you choose based on how complex a specific task is. Next is the implementation. So you can use no code tools like Flowwise, Langflow, and N8N, and or use a code like frameworks like Google ADK, LangChain, or AutoGen, which gives you a more control. The production For production use, we you need to have a strong frameworks. They should be open, flexible, and easy to monitor. This is called production grades. For example, observability. The agent instruction strategy. So this means how we guide the agents. We set its role, tone, rules, the guardrails, and the format of the output. We also give examples and domain knowledge to help it work better. Next is the memory and the context, which is also a very important aspect while building the effective agents. The agents needs to remember what they are doing, track actions, and reset when needed. This helps them make smart decisions in real time. And the long-term memory, this helps the agents remember across sessions, learn from the history, and improve the time. It also does the personalization. So these choices help us build agents that are smart, reliable, and useful in the real world task. Explore how agents can work together to solve a complex task. So we have a design patterns available, which we can make use of while designing effective AI agents. So first we have a sequential agent patterns. Here, a user gives a prompt and the agent completes the task one after the other, task A and then task B and then task C. Each step build on the previous one. Next, we call this as a coordinator agent pattern. In this setup, a coordinator agent receives a user's prompt and dynamically routes the request to the right sub agent for each task. Intermediary outputs are sent back and forth following for a flexible orchestration. Finally, we have an iterative refinement pattern where the agent generates an initial output which is evaluated by the quality evaluator or a human in the loop. If the output does not meet the requirements, a prompt enhancer sub-agent improves the prompt and then the process repeats until the quality score is high enough. These patterns enable agents to handle dynamic or a non-linear task and collaborate and continuously improve their results. Yeah. Once an agent is built, it needs to be deployed to a runtime environment like the cloud or a server so it can operate continuously and serve users or other agents. Deployment is what gives the agent its body and legs, enabling it to execute tasks in the real world. The key services for agents in the production include session history, memory persistence, logging, and security compliance such as data privacy and residency regulations. Agent builders can use platforms like Vertex AI Engine for integrated deployment or choose Docker containers or services like Cloud Run or JKE for more control. For non developers, many frameworks offer simple deploy commands to make the onboard easier. Uh, Now we get to hear a new term called agent ops, which is nothing but it's a combination of DevOps and MLOps principles to handle the unpredictability of generative AI. So this includes automated evaluation using language models as judge, metrics driven development for goal completion, latency and cost A/B testings for safe rollouts, and open telemetry traces for debugging and human feedback loops to improve agent quality. So in this final slide, we will discuss about the agent interoperability. And this refers to how different AI agents and even humans interact and work together seamlessly. So these are broken down into three main categories as you see on the slide. First, we have agents and humans, which falls under what we call human in the loop or HITL protocol. This is where the human oversight and decision making are integrated into automated process. It's about combining the efficiency of AI with the nuanced judgment and creativity of the humans. Next, we look at the agents and agents governed by the agent to agent or A2A protocol. This is all about how different AI systems communicate, share information, and collaborate with each other without direct human intervention. Think of it as a language and a set of rules that allow AI systems to understand and respond to one another. And finally, a very practical and increasingly important area is agents and money, which operates under the Agents Payment Protocol or AP2. This addresses how autonomous agents can securely and efficiently handle financial transactions, make payments, or manage monetary resources, often in a decentralized environments. Understanding these protocols is key to building a robust and scalable and truly intelligent systems that can operate effectively in a complex real world scenarios. And that brings us to the end of today's video. I hope you found it helpful and learned something new. If you did, don't forget to like, subscribe, and hit the bell icon so you don't miss the day 2 of the series. Got questions or thoughts? Drop me in the comments. I would love to hear from you. Thanks for watching, and I'll see you in the next one.